Hi, today we are going to talk about the process of death. We're going to talk about how to determine specifically somebody's time of death. When we talk about time of death, we usually abbreviate it TOD. So determining someone's time of death, they use kind of three factors in order to do that. Keep in mind, death is a process, not necessarily an event, right? Your body kind of slowly stops functioning after the initial impact of whatever it is. A pathologist determines somebody's time of death. They're the individual who is able to determine a time of death. So let's dive into the three things that they use to determine somebody's time of death. If you are in your notes in class, it would be the top three tabs in your foldable. If you are online, it'll be just on your notes paper. So the three physical methods for determining time of death, the first one is alga mortis. And alga mortis is the cooling rate of the body after death. So the temperature of the body is not able to maintain its constant temperature anymore. So normally, when you're alive, your temperature is 98.6 degrees, right? Fahrenheit, approximately that. When you die, your body doesn't have the ability, your heart's not pumping anymore, doesn't have the ability to keep the temperature at a constant, and it begins to equalize to whatever environment you're in. So normally the temperature goes down most of the time, but it will technically just go to whatever temperature the body's in. So if someone were to be killed in the middle of the desert in Arizona in July and it's 120 degrees out, the body temperature will rise to 120 degrees, whatever the temperature is outside. If somebody is killed or dies inside and it's a normal room temperature, say 75 degrees or so, the body will cool to that temperature. And so scientists have studied this, and they determined that there's an equation. It's called the Glacier equation. It's used to estimate somebody's time of death. They can't get it like 100% exact, like they died at 9:57 p.m., but they can say they died between like 9 and 10 o'clock. And here's the equation. You'll want to write this down because you'll use this. It's hours since the person died. Here's how you figure it out. 98.4 degrees Fahrenheit, which is a regular person's approximate temperature, minus the internal body temperature of the body that you just found, divided by 1.5. And the reason that the 1.5 is here is because you lose approximately 1.5 degrees per hour is what they've found. So as soon as you die, approximately every hour you're losing approximately 1.5 degrees of body temperature. So let's do some practice with this and show you how this works. So a body is found outside Sky Harbor Airport Terminal 4. The body is examined and has an internal temperature of 78 degrees Fahrenheit. So approximately how many hours has this person been dead for? Well, you would plug it in to the Glacier equation. So you would do 98.4 minus the temperature of the body, which was 78 degrees, divided by 1.5 would be what you would do. So you would do 98.4 minus 78, then you would divide that number by 1.5, and you should get about 13.6 hours. So what they would say is that the person's been dead between 13 and 14 hours. So they usually just do an estimation at that point. So the person had been there outside of Terminal 4 for approximately 13 hours. So for the second one, it says a female victim is found dead inside her home in North Phoenix. Her body's internal temperature was 92 degrees Fahrenheit when she was found. How long has it been since she was killed? So again, you'll use the same thing. So you'll do 98.4 minus 92 degrees was when they found her. So you'll do that and then divide it by 1.5. And if you try that, you should get about 4 hours. 4.3 hours is what you'll get in the calculator. They would say approximately 4 hours. So she had been dead inside her home 4 hours before she was found, which makes sense, right? 92 degrees is not as far off from our regular 98 degrees as 78 degrees is. So it would make sense that she had been dead less time. this kind of go the other direction as well. So it says an elderly man dies at a nursing home. He's been dead for 4 hours. What's his current body temperature? Well, we can just kind of go the other direction, right? So if we want to figure out what his current body temperature is, we know that he started at 98.4 degrees and he's losing 1.5 degrees an hour. So you can do 1.5 times 4, right? Which would be 6, right? So he's lost 6 degrees, and then you would just take your 98.4 minus 6, and it should be 92.4 degrees. So that equals 6, and then you would want to do your 98.4 minus 6, and you should get 92.4 degrees. Okay, so his body temperature would be 92 degrees if he's been dead for 4 hours. All right, so that's the Glassier equation. And if a coroner or a pathologist gets called out to the scene of a crime, they usually have a thermometer. It kind of looks like a meat thermometer, right? And they stick it into the body. It gives them the internal temperature. They usually try to hit like the liver, like an inside area. Take the internal temperature of the body, and then they're able to approximate a time of death based on that. So that is the first physical method for determining time of death. The second physical method that they use is what's called rigor mortis. So this will be your second tab. Rigor mortis is the purple or red discoloration of the skin caused by the pooling of blood after death. So as soon as you die, obviously your heart stops beating and no longer is circulating all that blood in your body, and it kind of has to settle somewhere. So however you're positioned and or sitting or lying or whatever it is, the blood kind of goes down, right? Gravity takes effect and the blood just pools down at the bottom. So this starts within a half hour after death. So within a half hour after death, the blood starts pooling in whatever location it goes to and is most evident within the first 12 hours. So it's like most noticeable then. So for example, if you were sitting, say, on the couch and were shot, right, your blood would pool downward. So most of it would probably pool in your butt and the back of your legs, and some of it would pool in your feet, right? If you were lying face down when you were, like, so say you were shot and then your body was just face directly down on the floor, all of your blood would pool in your stomach area, your front of your legs, and your face. So whichever way is closest to gravity is the way it's going to pool. So like you can see this person right here, right? They were lying on their back with most likely their legs up. All their blood pooled here. So they were lying face up. This individual, same thing. They were lying face up. All their blood pooled down here. This person was lying face down and most of their blood pooled right here. Or maybe they were on their knees at some point and that's where the blood pooled. The interesting thing to note after this, or for this one, is after the 12-hour mark, after the 12 hours, the discoloration will not move. So basically, if a body's been put in that, like the same position, and then all of a sudden somebody moves it later on, and it doesn't make sense where the blood is pooled at, after 12 hours, the discoloration just physically stays where it's at. The blood is basically clotted and agglutinated in one place, and it's not going to shift anymore. So if investigators get to the scene of a crime, say 2 days after the person has died, and all of a sudden they're looking and the person's sitting up in a chair, but all the blood is pooled in their front of their stomach and the front of their legs, they're going to know the person's been moved because it should have been in their butt area and the back of their legs. So sometimes they can tell if a body's been moved based on where the rigor mortis set and where, if it makes sense. So that is the second physical method, is rigor mortis. The third physical method is rigor mortis, which I'm guessing almost all of you guys have heard. Oh, I saw somebody in full rigor, or somebody is in rigor mortis. It's the stiffness in the muscles that occurs shortly after death. So it's basically when your muscles like stiffen up right after you die. It's kind of a weird thing to see. But when you die, your muscles immediately relax. The ATP begins to break down, like all the extra stuff that was in your body, and fluid concentrations change, and it causes your muscles to contract, like almost kind of automatically, and your muscles become rigid. It's very noticeable in the small muscles first, your face, neck, jaws, and then it moves to your larger muscles like your quads and your biceps and triceps and different things like that. It appears, a body will appear to be in what's called full rigor, usually within 3 to 4 hours, and all of rigor mortis is completely gone within 30 hours. So it's kind of a process. So if you look down here, if you get to the scene of a crime and the temperature of the body is warm, so you touch the body and it still feels warm and it's not stiff yet, the body hasn't stiffened yet, they haven't been dead more than 3 hours. So they're usually like 1 to 2 hours from their time of death. If you get to the scene of a crime and the body is still warm, like it still feels fairly warm, and it's stiff, it's starting to stiffen. So it's really kind of awkward to move the body because the muscles are all contracted. The person's been dead approximately 3 to 8 hours. So usually the person is in full rigor by 8 hours. So between the 3 and the 8 hour mark, the body is stiffening up. If you get to a body and it's cold, the body feels cold to the touch, but it's still stiff, it's been between 8 and 36 hours of time that's passed. So usually the body is in full rigor, like complete rigor at the 8 hour mark. And usually the body's also cold by that time because it's gotten to room temperature. It's lost enough degrees per hour. So between 8 and 36 hours, the body will be cold and stiff. If the body is cold but not stiff, so the body's cold but it's completely relaxed, it usually means the body's been dead for 36 hours or more. So about a day and a half or more. Rigor will have been completely gone. Everything will have been used up, all the ATP and the fluid concentrations, and the muscles will relax themselves again. So scientists and pathologists use all 3 of these to determine somebody's time of death. So they take a look at alga mortis, the temperature of the body. They take a look at liver mortis, and they take a look at rigor mortis. And using all 3 of those things, they estimate a person's time of death based on those 3 physical methods. So in your notes, if you're in your foldable, right next to it, if you are online in your notes, there's a spot for it. I would like you to draw a picture example of somebody taking somebody's temperature for alga mortis, an example of what liver mortis would look like, an example of rigor mortis. So draw a body and show them in alga mortis, liver mortis, and rigor mortis so that you have an example for each one of those in your notes. You may find a picture online and print them and put them in, or you may just draw a picture example of a body and add in things to help you remember all 3 of the different mortises. And then at the end of this assignment, there are some questions for you to answer. They're alga mortis, liver mortis, and rigor mortis questions for you to determine time of death. Make sure you do those as well.